See?
Right.
You can see that. And if I turn the gate the other way, that means the spin's going to go the other direction, right?
Mm-hmm.
See? And it's going to suck through.
Yeah.
See? I can put it down.
Yeah. And just to reiterate, the ball bearing is just there just to distort the field of the small magnet.
Yes, that's all it is. In other words, what I really want to look at, and it's hard to draw because what I want to look at is something that sort of looks like this. So I'm trying to do something because I've distorted these lines with the iron.
Sort of like the bow of a ship.
Yes. And so, you know, when we come to the conclusion, you know, what did Floyd Sweet do, right? Floyd Sweet actually changed the magnets. Floyd Sweet's machine looked like it was an attraction. Not an artist. Okay? It looked like it was an attraction north, south, right?
Right.
But when we analyze it, Floyd Sweet heated these magnets and then recharged the magnet with the signal that he wanted so that he could orient the signal in the magnets. So that when the oscillator came into the magnets, he was making a very, very, very nonlinear magnet because Floyd said he was getting to the nucleus of the magnet, which very well may be.
Yeah.
You know, but he had a cross-wound coil.
Right.
Right? And by putting the signal in at the blotch wall, down the center.
Right.
See? Remember I said in the beginning somewhere in the film that there's this blotch wall that's running around the magnet. But I said there were 4 quadrants.
Right.
So that there's one that's running this way too. See? That's in between. This might be an easier way to say it.
Right.
That's in between these lines that are in motion. There's a blotch wall, or I call it a delta zero here. There's one here. And there's one across the magnet. So if I come in, and I'm really clever, and I figure out the exact point of this blotch wall, I can modulate it. If I modulate it, and my magnets have been conditioned to be asymmetrical, right?
Yeah.
Then what's going to happen here? This was a north pole and this is a south pole. They're going to start switching back and forth. Well, what's 90 degrees from that? The power coil. Right?
Yeah.
Well, it's going to make a dipole. One set of spins are going to go down the wire this way, emanating from it, and the other is going to go down the opposite end, and you're going to get AC. You're going to get this. You're going to get this wave out of it.
Yeah.
Unless you rectify it. And so you're making this structure, you're programming this structure the same way Howard Johnson is programming his gates.
Yeah.
And they're stationary.
Yeah.
Okay. So.
Yeah, I bet most people never even thought that there was any sort of similarity between what Floyd Sweet was doing.
Oh, no, there's a lot of similarity. People just term it completely different.
Yeah.
And the point is to be able to measure, to understand that if you're going to make a magnetic structure and you're going to cut the pieces with a rock saw, and you're going to go this direction, and then you're going to tip this one, right?
Yeah.
And so you tip it over here, right?
Yeah.
You know what's going to happen to the field.
Yeah.
You just know that when you start to measure things out, it's going to look, you know, it takes thousands of data points to get the field out of this.
Yeah.
And this may be in repulsion, you don't know, and it may want to go like this, out of here somewhere. See?
Yeah.
And you're going to get this strange looking magnetic field that's going to give you something that's going to look, you're going to get something that looks like that.
Yeah.
Right? And Howard made so many of these strange magnetic structures that once again I have to go back here and show you. I'm going to leave it down here because it might be better.
Well, hold it up a little bit because I can't get the. That's good.
Oops.
That's good.
That you're going to get these type fields. I mean, look at this one.
Yeah.
So now let's look at Howard's train. So this is a train, and I want everybody to notice that look at the way these gates are made.
This is Howard Johnson's original gate.
Yes, this is original gate.
Or his latest. This is
Right.
the one that he was really proud of.
Right, because look here, this is Neo. Look at this. Look here along.
So what are you actually?
I'm showing you that it's alternating all along here.
Let me come around the side then. Oh, while you're doing that.
And let's go on the inside. And if we go along the top, so you notice that Howard's gate on the train, he's made up these gates with alternating magnets. You can look, maybe you can get a real good close-up shot of all these gates. And he says that this one, see Howard puts dots. He puts dots in the direction of the fields. See them?
Right.
North, south, north, south, north, south, north, south. See here? And if you look down the side here, when we laboratory tested this, you can see the magnetic fields in Gauss. 13.05, 14.1, 15, see, 16.2, 17, 18, 17, 20. It's pulling this way, right? See, and it keeps climbing.
Yeah.
And notice what he says here, that the car's magnet is shaped south-north. So that means that when you look at these magnets, see, he's made this curved magnet up. Look. And you know why it's alternating? Because Howard has the two particle spin theory.
Okay.
And so by spinning in one direction with a hard field and then spinning the opposite direction with a soft field, he can pull this car through here. Like that, with acceleration, because it's spinning. He can pull this car through here because it's spinning.
Right.
See? And if we reverse the direction of the car,
Yeah, try not to hit your cameraman in the,
see, you got to orient it the right direction,
right,
or it's just going to come flying out of that gate, see?
right,
Because that's a gate right there. See it?
yeah,
It's doing the switching right now, right here.
yeah,
See how the field's nulled out? I'm not getting a field.
huh,
See, it's zero in here. There, right there, I'm getting it. See? And there it just switched.
right.
See?
I can't get a shot of the,
See? That's the field that's affecting it.
oh,
See? Now watch. If I turn the car around, if I can get the wheels on it, it's going to go that direction, see?
right,
And it can sit in the neutral zone.
right,
See? Look, I can't force it. See? There's a null. Null. So what's happening is the gate's nulling out until it gets to the end.
right,
Watch here.
yeah,
See? And Howard's made up all these magnets. So he just made up the banana magnet that he wanted. And he's done this. If you look very closely, look, here's a piece of rubber magnet. See, look, neo, ferrite, rubber, neo, ferrite, rubber. See here?
right. Yeah, and in actuality, in the first DVD that we did with Howard Johnson, there's a schematic of the way the magnets are laid out, which shows this.
Right.
So it's worth studying it.
Now here, if you'll come around this side, here's the other thing. He curved the field underneath here, see it?
Right, I always wondered what that was.
Well, look at this. See, it's a north end this way.
Yeah. And he used to keep a piece of wood over there so you couldn't see
Yeah,
it.
right, because that's a banana magnet underneath there.
Yeah, but it
If
was
you
kind of a
look-
secret that
Yeah.
he had it under there.
Right.
Yeah.
Well, there are no more secrets because we're explaining to you what he did.
Yeah.
You know, now I want everybody to understand that I'm keeping this on a very simple level because not everybody's technical. But what's actually happening here with when you arrange a magnet like this, and then you just off the wall decide to put a magnet here like that, which he's cut all these different shapes, right? That when you run these magnetic fields, this may be a north here, and this may be a south, and this may be a north, and this may be a south, and this may be the blotch wall of a magnet that he's cut. You follow me?
Yeah.
With a piece of rubber in between.
Right.
And they're all glued together. So when you run a magnetic indicator or a Gauss meter over this XY plot, you're going to get a dot, and 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 you're going to get a dot. And these are all measurements. All right? And you're going to get dots, you know, in Gauss. And that's what you see right along here with these numbers, because we've already measured this for you. And you can see what the magnetic strength is as the car comes through the track.
Let me go through it first. Yeah, it certainly takes a lot of the mystery out of it.
Yes. And so by getting these dot points, then we can go ahead, and this takes a lot of work, folks, it takes a lot of work to do this, because you got to take your time, and you're going to measure this stuff out. And you're going to have all these points out here. So you're going to end up when you connect the points, right? You have the computer connect the points, it's going to start generating fields. See? It's going to start generating these fields. Because there are going to be all these points in here.
Right.
And this takes hours and hours and hours to figure out exactly what this field looks like. And what Howard has here is a complex gate, which does one thing. It's going to change polarity when the magnet goes by it. It's going to want to switch these polarities. And so if you looked at this, if you look at it in real simplistic forms, it spins. It spins. It spins that direction, right?
Yeah.
And the other side spins the opposite direction, which drives the car through the gate. So everybody, I hope everybody learned something from what was just explained here, but here is what it leads up to. Knowing what the gate does, it leads up to a disc. It looks as if you're looking on it straight on like that. But what you must remember is that it's depicting angles. And they're not quite even all the way around. So basically, if you're looking at this, you're looking at a snail shell, basically. So that means then
Fibonacci spiral?
Yeah. That means that on this line here, this isn't quite drawn exactly the way I want it to draw, because it comes in a little bit straighter than that. And it comes in a little bit straighter than this. And it comes in a little bit straighter than this. Okay? And a magnet is placed here. And a magnet is placed here. And a magnet is placed here. Okay? So that means if this is north, south, north, south, because you saw the indicator go by the gate, north, south, that gives you 3 magnets on the top of this disc. Okay, and that means you're going to break this. That's what Howard was doing in those pictures. You're going to break this with 3 more. And what it's making up is a V-notch. See? All right?
Yeah, that's right.
So I did see something very close to this on the internet, but this is exactly what Howard Johnson was doing. And these all stay the same. So if this side's a north, this one's a south, and this one's a north, and this one's a south, and this one's a north, and this one's a south. Okay, and it stays exactly the same all the way around. So that when you end up, here's a south, right? Here's a north, here's a south, here's a north, here's a south, here's a north. Okay, and it just keeps going this way.
So that circle is completely filled up with that? Is it
No, it's just...
We're just going to use 9 magnets, or
Yeah, you just use 9 to get to start with, but yes, Howard was going to go all the way around the disc.
Yeah.
All right, so I'm just showing you the simple little thing. And so here, this one's going to be a south, and this one's going to be a north, and this one's going to be a south. And I don't want anybody to get confused, because this is what it is. So when you go around with the magnetic indicator, red, green, red, green, red, green, red, green, red, green, except for one thing here. These magnets are facing, when you look at the side of the disc, they look like this. Pay very close attention. You have a north over here, and then on the other one you'd have a south, see? But you're only going to go across one gate at a time. But look at the angle. The magnet is sitting on the disc this direction. What did I say about this? I said the blotch wall was in the center. So what are we going to do? So all we got to do is put, if I get rid of this, I don't want you to get confused with all these letters. If I put a horseshoe magnet, just normal, north and south, above this at the correct angle, this is going to rotate. It's not going to go very fast. It's not going to run your house, everybody, but it's going to tell you that Howard Johnson was building an over-unity motor. This is what he was going to do, but he was going to change the angle into a V-gate. It's a little more complex than what the people can do right now. See, as it spins. He was going to hold a stationary gate and movable gates and then a gate above it, and it was sort of going to be shaped like this. Disc, and it was going to come through a gate that was shaped like this. And that was going to make up the horseshoe.
And that last gate that you drew is essentially a horseshoe magnet.
Yes.
In that kind of configuration.
Yes.
Yeah.
When Howard is showing you these squares that the train's running through,
Right.
he has made up a gate that sucks the magnet in with one polarity on the outside. But if I could draw this three-dimensional, and I was an artist, which I'm not, you would see that these were all north-facing inside.
Right.
See? And that this was, that as you come into the tunnel, it's got a south-facing side.
Right.
Because of the way he's shaping the magnets when he's cutting them. You follow me? He's cutting them with his rock saw to fit together, and he's make suring that there's this material in between that may be a rubber magnet that allows the blotch wall to shift.
Right.
You follow me?
Yeah.
And then this will go from north to south or south to north depending on what is going through that gate. So in reality, what I've shown you is something that, and we've seen this, Tony, on the internet. Somebody's got one very close to it.
Right.
But not Howard Johnson's. Howard Johnson's is already here.
Yeah.
And the man knew exactly what he wanted to do. He was up there in the years, and I'm sure he was sick towards the end, but Howard wanted this stuff released to the public. He wanted the public to know what he was doing and how his magnets were working. And I've kept this on a really simple level for everybody because I'm not going to sit here and feed you a bunch of math and get you into something when I can just tell you how to do it. And you can experiment with it. And not knowing these data points. So we're talking about a magnet that's maybe, 1 7/8 inches long, 3/8 inches thick, by, 3/4 inches wide, okay? That's all we're talking about. We're talking about a Briggs & Stratton magnet that everybody used in the SG group or any group that is familiar with my work. And this is the way it was laid out. It's laid out at a specific angle, using this spiral.
Yeah.
You see? And that makes up, when you're looking at this, I'll redraw this so they can see it one more time. But
Yeah.
see? Think of your 3 magnets like this. And your next 3 magnets like this. You gotta have good bearings on this thing. It looked like Howard's pretty good bearing system there. Looks like Howard was gonna go for high speed is what it looks like, all right?
Yeah.
So you're basically looking at that. I'll say this again to you. If this is a north, this is a north, this is a north. See? And you keep going around the disc.
Yep.
You see? South, north. See it?
Yep.
And you do this all the way around the disc.
Right.
All right? But when Howard's laid out, instead of using a normal store-bought horseshoe magnet, all right?
Right.
Howard's gate went like this.
Yep.
See? And what is Howard doing? When it's sitting on this rotor plate, I'm blowing up a magnet. It's sitting on the plate, right?
Right.
Axle through here. Magnet looks like this, right? When you're looking at it, this is the north-facing pole, opposite south side, north, south, north, south, north, south, north, south, all the way around, alternating, right? What is running the engine is it's crossing the blotch wall.
Yeah.
It's nowhere near the magnetic fields.
Great.
So it's vacuum energy in a spiral form that's running. I'm going to show it to you one more time with the gate. The spiral that's going to run the engine is just like what I showed you here.
Beautiful. Great.
A lot of submarine transmissions. Howard was brilliant in the way he laid out this wheel. You can see here that each one of these magnetic structures underneath is asymmetrical. See it? See, it would be over the top here, it starts to narrow here, it gets narrower, 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 narrower. See, until it's almost, and then it does something completely different here, right? And what I noticed is that the gate has to be sort of constructed like this, and these magnets have to be cut to make up Howard's magnetic structures. See, a piece of neo here, neo, magnetic rubber. And it's these angles that you have to cut, you know, which Howard used the rock saw for.
He had a diamond tip saw, yeah.
Yeah, you have to have a diamond tip saw to cut the ferrite blocks. And so I'm going to draw the gate structure.
Okay.
And Howard has, according to his drawings there, said that this has to be in a bearing. Right here, and he shows that. So I guess the bearing's going to go through here. And these magnetic structures here.
So the gate is on a bearing?
No, the wheel's on a bearing.
Oh, okay.
Yeah, he has it on a bearing, and I think he was working on his later one shows 2 bearing supports at each end. Okay.
Right.
And the gate is the thing that's very important because it's got a slice of neo. The gate actually looks, you know, sort of like this. But this portion of the gate, right, this all becomes, say, a south, so that it attracts in this north over here.
Right.
And then this flips, because of the way he's got this arranged with, these are actually cut pieces, cut blocks of magnetic material. So see, if this is, this portion here would be sort of the center, but in between here he's got these rubber magnets, which I've showed you on the train car.
Right.
And these are all made up of pieces, and these are neo-tipped. And some of them are split, which means there could be 2 souths here. See, and this becomes a real strong north.
So where's the split?
Right here. So if you looked at this portion, the way he's tipped it is with 2 small pieces
Okay.
of neo. Now,
Right.
let me give you an example of the gate here that we're going to work with. And you can see it's a dual gate, see? And see how the poles are stronger here and here, and the thing moves by, and then it switches. I mean, we're talking about I have 3 dual gates to work with here on this motor, because they're not all the same. You see what I'm getting at?
Right.
So we look, you know, at Howard's gates. See, here's the gate face. See? South, south, south. So as the motor comes inward, right, as this motor's attracted, let me get this out of your way. If we're looking at the motors on this disc that Howard's building, right, as this, if we just put one magnet here like Howard's doing, and we say this is a north and this is south, this is a stationary magnet. Nothing has been changed on this magnet, okay, but let's say it's coming into the gate. So the gate is something like this, and it's down below the motor. In other words, this end is going down below the motor, see, and the gate's coming back around below, like this. See? So it's like a U, almost.
Right.
Right. But some really, this magnet, even though that this is a north polarity or a south polarity on this side, right? It has to attract this magnet in. It has to, before any switch can occur, we have to have the magnetic fields, if it's like this on a plane, and we have this magnetic field, this is the first switch in, and this is the second switch out. That's what he's depicting there, and he's depicting the magnetic field this way.
So what's the thing up on the top? Above the waves, what's that up there?
Up here?
Yeah.
Oh, this is where the strongest part of the magnetic field is.
No, but my question is this. Let me just point. What is this up here?
Oh, just space.
Okay.
We're not worried about it.
What is this line here then?
Okay, this is the gate. Let me go back to this again so you can see.
Okay, got it.
See what it is?
Yeah, okay, got it.
So what has to happen here is, even though this is a north side, right, a north pole in, underneath,
Right.
and this is a north underneath, right? Actually, this becomes a south with Howard's gate. But anyway, what has to happen here is this is going to repel. You follow me? So Howard's tricked the magnet into this type of field where it sucks it in, and then it's got a break point, a neutral point, and then it's got one hell of a push out.
Yeah.
You follow me?
Yeah.
So the face of this thing, the face of this gate, and look at it this way, it's like a box, has to look to the magnet like it's south.
Yeah.
Notice I said it has to look to the magnet, to this magnet like it's south, so it can pull it in.
Right.
Because we don't want it to come here, get this far, and then repel and push back.
Right.
See?
Yeah.
That wouldn't do very well, right? So inside here, in this box, see, this gets very complicated because Howard is like in 3 dimensions. See? And this is north now. So it's like a north tunnel.
Yeah.
So here's what has to happen with this little simple experiment. Remember, Howard Johnson was brilliant when it came to the 2-particle spin theory. So if we're saying this is the gate, it has to be attracted like this, which means it's being sucked upward. See?
Okay. Right.
And it has to spin, and that gate turns over, and the spin goes the other direction and
Right.
pushes it out.
Right.
So remember what I said, you know, everybody thought, well, what is John doing this flux gate in the year that he did it, right?
84.
I was studying these spins, the right hand spins on the same pole. See,
there's two sets of spins on the same pole. Because if I put an arrow here, up, right?
Oh, where's the arrow? Right.
You see, I get a spin, right? See it? Not here. Get over here where you can see it there. And get it right.
Down, boy. Got it.
See?
Yeah.
And if I turn the gate over, it's still the same north. I get the opposite spin.
Right.
Well, how can that be?
Yeah.
You've got one north pole, right?
Yeah.
Well, it's the gate. It's the vortex spin. It's his theory. Exactly, his two-particle spin theory on the same magnet. So you know what that means? When we look at all this, that means that Howard Johnson knew how to take this one signal magnet, right, and divide it in two.
Yeah.
So he knew that if he made this gate, right, that he knows that the spin's going to go one direction this way and the spin's going to go the other direction this way. But since these are all north poles facing each other around the gate, right, they do spin that way. One is going to spin this way and one is going to spin that way. And this proves it.
Yeah.
That he knew exactly what he was doing, because I can get the spin to go that way. And I can get the spin to go this way. And this is the same pole. So you don't see a south anywhere here.
Yeah.
And if I turn it over, it's still north. But when I draw it like this,
As a gate, with all these magnets, this is inside this gate, right? And on the outside of this gate is going to be all south, and on the inside is going to be all north. What happens is when it gets to the center, it starts to spin this direction, and when it gets here, it goes the other direction. Well, that's what a motor does.
Yeah.
You know, you come in and you have this pole, right, that's north, and when this pole comes in on the motor and it's north, it's repelled out, right? You see what I'm saying?
Yeah.
But if I was to switch this, this would then be a south it'd be attracted in, right?
Yeah.
because this south is attracted by this north. And it's still spinning. So when you build this Howard Johnson motor, which I know most people will probably try to attempt from this DVD, and you have to understand the way Howard thought about magnetic fields, and you must remember that Howard's magnetic fields are strange. He's cut these magnets, right, to interlink. So suppose this was a south, and this one's a north over here, and he put another south here, and he put another north here, but he bonded it, you follow me?
Yeah.
And then he tipped this with a piece of neo, right? This field is pushing outward up here in dots. See? Because it wants to push outward this way. And this one wants to push outward this way.
Yeah.
You see? So depending on where he's placing this gate, you know, and he's making this gate, the magnetic fields are going to look really, you know, when you plot them out, see?
And it's much too complex to go into for people that don't, don't design magnets in this documentary series.
Yeah.
Unless, they're going to try to design magnets, but Howard's done something, much more unique in that he's used a piece of magnetic rubber in between here. And then he's cut his block. And you can see that on the train. And then he's even cut it at a funny angle where it goes out like that. Now what's the magnetic field, right? Until you plot this out, I mean, this magnetic piece of rubber does not have the strength of these two magnets.
Right.
So it's right where he wants it to switch.
Yeah.
He wants it to switch at that point.
Where does he want it to switch?
This is neutral in here.
Right, right.
It's low magnetic field on both ends.
Right.
It all of a sudden comes into the gate at an angle, if you can look at it here. See? It's like looking at it like
Right.
instead of climbing the mountain straight up,
Yeah.
Howard's taking it at an angle.
Yeah.
A good indication of that, and we'll go back to this for a minute, is this is the cuts in the magnet. This is the wheel. That's kind of strange, isn't it? The twist motor, he called it.
Yeah. Yeah.
So if you're looking at this magnetic structure and you notice that he's got a green here and he's got a red here, and look what he's got right here. He doesn't say.
Where that X is, the cross.
Yeah, he says 13, which is magnetic rubber,
Right.
okay? See, rotor,
5 rotor.
yeah, 5 rotor, number 5 ferrite, right? So actually what we're looking at is something that's kind of like this, right? I'll get it as close as I could. And then there's this gap in between. And not quite so much of a gap on that angle, see? So when you look at this magnet, if this is the North Pole and you end up with it, I'm not going to draw the whole thing
Right.
because you can see it right here.
Yeah.
Right? It's a 17.5-inch wood wheel that he's playing with. So you know that this north, right? See, this south is shortened,
Yeah.
you see? And this is magnetic rubber, something like that in between.
Yeah.
Because when the magnet comes by, he wants the switch to occur.
Right.
So what he's done is it's brilliant. He's made magnetic switches. See?
Sort of like Radiss's boots.
Yes, exactly like Radis.
Right.
He's locking in a memory in this magnet.
Right.
By the way, he's cutting it and fitting it together. It's almost like nature, like you're looking at a crystal, right?
Right.
And I can relate to it really good because I've built plenty of crystals in my life in the oven.
Right.
And I know what the makeup of those crystals are, and some of them were magnetic crystals. But Howard can't go and buy a magnet that sort of the graining is, and I'll give you an example. If you had the magnet, and you know that the grains in that magnet are tightly packed, right?
Right.
And the more you pack those grains, and when they energize and they line up, right?
Right.
The higher the magnetic field's going to be.
Right.
But suppose you only have a few on this pole, and a lot on this pole.
Mm-hmm.
You see what I'm saying?
Yeah.
Then this field here is going to go like that out, and this field here is going to go like that in.
Yeah.
See? And when you look at this, if this is the north, this is the south, you can see the south area is far stronger.
Yeah.
But Howard says, let's cut this, put a piece of magnetic rubber in here, which is not, we don't know exactly the material yet that he used, right?
Right.
But we're working on that.
But there's plenty of that available out there.
Yes, and you can just get it anywhere. It's
Right.
like tape rubber. So what Howard wants to have happen is, what if this conveniently stays all the same like this, but in this condition with the magnetic field out here, right?
Right.
See? Right? It's keeping it in this switched condition, right? But as this moves this way, this just like moves up. It just gets weaker, and
then
that
flips.
gets stronger.
Yeah.
See? He's making asymmetrical magnets, and you can see it right here, and you can see it. Let me show you one other block. See, look. He shows you the placement of the magnets, and then he shows you them put together.
So there's the placement of the magnets, right?
Right? This is where he wanted them.
And what's the tracing paper?
Tracing paper is where he wanted them.
Okay.
He traced the exact setup for the
Right.
gate that he's going to make here.
Right.
Notice you see, he indicates by these red and green marks, and the orange ones. This is a different material.
Right.
See, look here. It's cut in a shape.
Yeah.
See?
Yeah.
And he's putting all these gates together to make one magnetic field.
Right.
That looks sort of like that.
Ooh. Yeah.
There's one strange magnetic field.
And very asymmetric. Hugely asymmetric.
Yes.
John, I have a question.
Yeah, sure.
Thinking about this and looking at the gauge down there and all of these magnets, it's all these angles, how could he replicate, or anybody replicate that for a commercial thing? I mean, every time you try to replicate
Well, you
it's really
can't.
different.
You see, you can't, right, not one person's going to build one machine the same.
Okay.
But what you can do is, by making the magnetic material, let's just take the banana, right? By taking this banana magnet, right, and changing the material in here somewhere. In other words, changing the mix of the material. You're gonna have to mold this magnet so that it contains these materials in certain areas in this banana magnet. That's exactly what Howard was doing. Tony, that's why he wanted to take the rock saw.
Right.
He said he had to take his rock saw, and he
Right.
had to start cutting all this,
Right.
right? Because he couldn't have made this motor without doing that.
Right.
Because he couldn't buy the magnet that had different materials in each area that were different. You follow me?
Yeah.
There wasn't anybody that was going to make this.
So by building a mosaic, he could tailor it to.
Yes, he knew he learned that a long time ago, with his theory, right? Because he said Feynman was the closest
Right. He said.
to understanding all this. But Tom Bearden one time sent me a book that said there's so many differences in magnetic fields and there's so many magnetic things, right? And each material is so different.
Right.
I don't think Howard was ever able to get the amount of money that he needed to go to a laboratory where they could mix the material for the magnet that he needed.
I think that was Cullerty's book on magnetic effects, and
Yes,
he said like there's 400 magnetic effects,
Yes.
and only like 200 of them are really known what goes on, and the other 200 no one really has a clue.
that's right.
And they've just actually reissued that book.
Now, if you look at this normal banana magnet, right, let's just say that's it, right?
Right.
You know the magnetic fields are going to go like this because you've seen it in science class,
Right.
all right?
Right.
But Howard's banana magnet doesn't do that. Howard's banana magnet, he's tipped, He's cut, he's added a piece of rubber, it's not the same, forget about this.
Double tip.
Right?
Yeah.
Some of these banana magnets, he's got a piece of rubber right down the center that's bonded together to make the magnet,
Right.
right? And then you put it in the machine, and this field lops way out like that and comes back like this. You see what I'm saying?
Yeah.
And so he's made an asymmetrical magnet.
Right.
Or we're in the nonlinear range. It's nonlinear.
Yeah.
It's not a linear magnet.
Yeah.
Because he wants us to do something.
And he knew in advance
Yes.
exactly what he wanted that magnet,
Right,
magnet to do.
right. He was.
He wasn't just like stumbling into something.
Oh, no.
Yeah.
No, he was.
He had a plan and he was executing the plan.
I don't think folks really understand out there, or the people, just what Howard Johnson was all about. If you look at his work, and you study his work, you know that the man, he never talked. He was very secretive. You'd call him up on the phone, and I'd call him up on the phone, and I'd say, "It's John," and he'd go, "Oh, hi. How you doing, John?" And I'd say, "Howard, have you ever heard of blah, 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 blah?" And about a minute would go by, and Howard would answer on the phone. And I'd say, "Howard." And we had quite a few conversations. It took me a long time to get through to Howard, and Howard to get through to me. But I don't think people understood that he never was going to tell you anything about how he was doing this.
Well, you have to
You
remember.
weren't going to see it. In other words,
Yeah.
if he was working with anybody, the person would be untrainable. You couldn't train him,
Right.
Well,
Howard's background was in cryptography.
yes, very
And
secretive.
You have to remember that after World War II, he was offered the job of head of cryptography for the Navy, and he turned it down. So that's,
You have to be a very secretive man your entire life.
yeah.
And Howard Johnson was very secretive. He never gave away his secrets.
Yeah.
It's only now that we can begin by what Howard gave to you, right?
Right.
And said, "Here, you guys can have this." I mean, why would he take the folder out from underneath his bed and hand it to you if he didn't want you to have it?
Yeah. Exactly.
Well, the answer is right here. He wasn't going to tell anybody what these actual gates were going to do.
Yeah.
But the clue that he left was this. See these? He has made the gates underneath this magnet that he's cutting, so that this thing rotates just like this. And I bet it would have been about that fast.
Right. Right.
And so I just
Look,
congratulate Howard Johnson, and I'm just going to say that, that sorry that he never talked to anybody, and nobody ever really took an interest in Howard Johnson because he never talked about it.
Yeah.
He just did his magnetic experiments at night and measured it out. Tony, this was a very long study
Yeah.
on Howard Johnson. And why would you build? I mean, it's like looking at the pyramids. Do we really know how they're built? No.
Yeah.
Do we know what the mathematical points of of the pyramids are? Yes.
Or what they're for.
Yeah, what are they for?
Yeah.
But when you figure out what Howard Johnson was doing here, believe me,
John
or I,
John
right,
Bellini, yeah.
or I, if I build this, right?
Right.
If I build this, just this block, it's a pretty big block.
Yeah.
What do you think that magnetic field's going to look like?
Yeah.
I'm going to tell you what I think it's going to look like. Because I got a pretty good hunch that this is one of the best switching gates if we just take this flat plane. And let's just say all these blocks are in there, right?
Right.
Well, how many spokes are in the wheel, right? This magnetic field's probably going to look okay. Why do we think that it's going to look like that? Because the waves indicated the poles, basically. So what Howard is actually building here is a fuelless motor that works just like an AC induction motor.
Wow.
He doesn't have any energy, he doesn't need any energy, because once he gets the magnetic fields to look like that, right?
Yeah.
The thing will rotate.
Yeah.
It has to rotate.
Yeah.
I mean, there are experiments you can do. You know, there's experiments that I've done in my life where I can tell you if you take a disc like this and you and say this is the magnet, and you take this magnet apart and you break this into all poles like this, right? If I put in here, right,
Yeah.
a shaft, and I bring a rod out and I face a pole magnet this way, right?
Uh-huh.
If I break a certain spot here, right, everybody knows if you start here with the magnet, it's going to go seek the neutral.
Right.
It's going to seek the delta zero. I call it delta zero. Okay? But if the magnetic field actually went like this, this thing would go, just rotate.
Right. Just cog around.
Just cog around. And that's, Howard shows it here. And he shows it right here with this unique magnetic stretcher, because he says the twist motor using spin units.
Yeah.
It's right there in black and white, everybody.
Yeah.
He gave you the folder because he wanted somebody to keep up his work. There's a very simple method that an experimenter can do to find out. He can take a magnet, right?
Right.
And he can add a needle end to one magnet. That's going to shift the blotch wall
Right.
so that this field's going to be big and this one's going to be a small field.
Right.
Yes, they can find out. They can do simple experiments with Gauss meters to find this out. They can data point every one of these points. They can even add a piece of material to the side of the magnet. And then the field is going to do, it might go.
And they can even refer to the plots that we've shown them in this DVD.
Absolutely.
It's a really good reference for them.
That's right.
Yeah.
Howard Johnson helped me when I had nothing. A $500 check came out of nowhere. And in the end, as you know, when the SG started to go and everything here, Tony,
Right.
and the book started to work, I wrote Howard Johnson a check and sent it to him. So I just want everybody to know that Howard Johnson might have been a very quiet man, but he was a very brilliant man.
Yeah.
And I was glad to help you out with this.
Well, thanks very much, John. Appreciate it.